I hope you watched the previous video. There we have seen why do we use Redshift Spectrum. So what is this Redshift Spectrum? What can we able to do by using this Redshift Spectrum is we can able to query the data which is stored under S3. Nothing but we can able to query the data which is stored under S3, and we can even able to get the tables from the S3, and we can even able to scan the files which are stored under S3 by using what? SQL queries. Okay. So when do we move our data from Redshift cluster to S3? Whenever we are infrequently accessing our data, then in order to reduce the cost, we'll move our storage from Redshift cluster to S3. So even after moving our data from Redshift cluster to S3, we can even allow to process the data which is present under S3. We can only able to read or load the data, but we are not able to update or delete the data by using SQL queries. By using this spectrum, we can query the data of files which is present in under S3 by using SQL queries. But by using the SQL queries, by using Spectrum with SQL queries, we cannot able to delete the files which are stored under S3 data. So now the question is, can we join the table of my cluster and my data file table? Let's say one of my table present in my cluster 2 and one of my table present in S3 data file. Can I able to join them by using this Redshift Spectrum SQL queries? Yes, we can able to join Redshift cluster tables with S3 data tables by using Redshift Spectrum SQL queries. If you want to join your cluster data with S3 data, the only option for you is Redshift Spectrum SQL queries. By using Redshift Spectrum, you use some queries. By using that, you can able to scan the data which is present under S3, and you can able to scan the data. You can able to get the data which is present under Redshift. You can able to use both of those datas, and you can perform join or analysis on that whole data. Okay. Yes. So since more space is available and less overhead on data distribution and networking, overall query performance is increased. When by putting the cold data or nothing but infrequent accessing data under S3 and treating the data same like Redshift table. So how we are treating the data which we put under S3, we treating our data as Redshift tables only, but we are just storing them like a files under S3. What do we call these files under S3? We call these files as objects. So, but how we treating them? We treating them as Redshift tables, right? So we can query these Redshift tables which are present under S3, and we can even join the tables from S3 and Redshift cluster by using the Redshift Spectrum with some SQL queries as well. Okay. So now let us see what happens. Redshift Spectrum. So in order to do this, in order to query the data, so by using SQL query, what we are doing here, by using Redshift Spectrum, with the SQL queries, we are scanning the data which is present under S3 files, that is Redshift tables. So we can able to scan the data, right? Yes. So Who can able to scan the data? By using what? This Redshift Spectrum can able to scan the data. Actually, Redshift Spectrum nodes are there. How your Redshift Spectrum can able to query or process your scanned data under S3 by using nodes. What? By using nodes. Who create these nodes, sir? AWS will create these nodes. We don't even need to manage these nodes. We don't even need to provide clusters for these nodes. Who will provide? AWS. We just use this feature of Redshift Spectrum. Then it creates as nodes, and whenever we run our query under Spectrum, what happens is it just scans the data which is present in S3 and process that data under the nodes, and it provides the results to where? To my main cluster, So from that main cluster, it will provide the result back. It will provide the result back. So let's say a new user queried for my old version car, that is Spark version car. Then what happens? This Spark version car is present in S3 as files, right? Yes. So now what happens is whenever he queries, the query reaches to Redshift. Now under Redshift we have these things, right? We have leader node and compute node, right? Yes. So we have leader node as well as compute node. So this leader node creates an execution plan where this execution plan will contain details about where our query need to be executed, and this leader node even break down our tasks and distribute the tasks. So to where it will distribute? To the main cluster or else to the Redshift nodes, that the query is then distributed to Redshift Spectrum nodes. Why? Because we are requesting for our old version car data. So that's why the data is present under S3. So in order to get the data from that S3, this main leader node will request the Redshift Spectrum. Then this Redshift Spectrum scans the data from S3. So this Redshift Spectrum scans the particular data from S3 and load the data inside nodes and process that data, and same as it is. Under these Redshift Spectrum, your nodes will provide you individual results, and these individual results again send back to your main cluster here under the leader node. So in the main cluster, you have leader node, right? So at this leader node, what happens? It joins all the intermediate results and produce the final output of your query and sends back to the client. So in this way, your processing happens under your Redshift Spectrum. So let's say if your user queried regarding Super Spark, then what happens? Your query first reaches to here under Redshift. Under the main spectrum, you're having data, right? So same like previously, that is since your data is present under the main cluster, your data is first your leader node will create execution plan and breakdown happens, and tasks are distributed among your compute nodes. From the slices, they are executed, and these slices will produce some intermediate results and provide back to the leader node. This leader node combine all those sub results and provide back the result to the user, right? So the only change here happens whenever we use Redshift Spectrum is the computing, whatever the compute node work that was done under cluster, that will be done at where? That will be done at Redshift Spectrum nodes. Only the computing task will be done by using the compute spectrum nodes whenever we are using Redshift Spectrum, right? Yeah. So by using this, what happens? all your compute intensive activity is pushed to where? To your spectrum nodes, right? Yes. So we require very less capacity to run our main cluster, and we are pushing all our load, that is compute intensity activity, to where? Redshift spectrum. So that's why we charge very less for this, and we only charge it for here under Redshift Spectrum. Still, since we are using Redshift Spectrum, we will be charged only for the data scanned from S3. We will be charged only for the data scanned from S3. So, based on demand of queries, Redshift Spectrum can scale up to thousands of spectrum nodes, and data is processed parallelly in this Redshift nodes architecture. Okay. Whenever a query is received to the Redshift, here in Redshift cluster uses very less processing spectrum. It uses very less processing capacity than compared to Redshift Spectrum. Why? Because under the spectrum, we are processing and computing all the compute intensive activity, right? Yes. So here what we are performing under the main Redshift cluster, we're performing only query, whatever the results that are processing. The leader node work we are processing under this main cluster, right? Yes. So that's why we're charged very less for this. And since we are accessing the data from this by using the Redshift spectrum, here for these things we are not charged at anymore. So we'll be charged very less. So what about cost is, each query you run, for each query, whatever the query that you run, based on that, you can using, you're running your spectrum, right? Yes. So what is the data that the spectrum scans under S3? For that you will be billed, and you will be billed based on amount of data scanned. What you will be billed only based on amount of data that is scanned under S3. Whenever you use Redshift Spectrum, then you will be billed only for the data that is scanned from S3. So we only charge it for the amount of data scanned on S3 whenever we use Redshift Spectrum, because all our compute processing will happens under these spectrum nodes, will be charged for the scanning only, right? Yes. So when it is recommended to use this, use S3, use S3 as cold storage, that is infrequently accessing data storage only. Because if we store hot hot storage in S3 and using Redshift Spectrum, then it costs you more compared to the Redshift cluster. So if we store this Super Spark data under S3, and if we use Redshift Spectrum, since the data is frequently accessing, so there will be a lot of scanning happens. So that's why we will be charged very more compared to the data storing in cluster and accessing it. So that's why what is recommended. So use this hot data or frequently accessed data under Redshift cluster only. Store this data in Redshift cluster only. Whereas coming to infrequent accessed data or cold data, you choose to store the data under S3 so that you can able to minimize the cost, and you can able to use the AWS resources efficiently. So if you want to put data, then there will be some commands which are available to you under Redshift, where you can able to put your data to S3, or else you can directly even able to put the data from other sources, that is directly from console, or you can able to put your data to S3 by using some catalog services like Glue, Amazon AWS Glue. So one more important detail about Redshift is a regional service. It's not a global service. So if anybody asks you is Redshift is a regional or global, then you need to tell that Redshift is a regional service. S3 also a regional service. If you want to connect from Redshift to S3, then both must be present in same region only. Then only you can able to connect from Redshift to S3. If not, you cannot able to connect. So if both are present in the same region, then you can able to connect. Okay, yes. So since S3 also regional and Redshift also regional, they must present in the same region. If let's say my Redshift is present in Hyderabad region and my S3 present in Hyderabad region, then I can able to connect from Redshift to S3. How can we able to connect, sir? So first we need to connect to this Redshift by using any EC2 instance, and then by using that EC2 instance, we can able to get the data from this S3. Since both Redshift and S3 are present in same region, we can able to get the data from S3 to this Redshift. Let's say if my S3 is present in another region, how can, let's say my S3 is present in Mumbai region and my Redshift is present in Hyderabad region. Now, how to provide a communication between them? So since they both are present in different region, if you want to provide communication between them, use a concept called cross region replication under S3. So while you are learning S3, I hope you learned about the concept called cross region replication. If you use that concept, then you can able to replicate your data across regions of S3. Your data of S3 will be replicated across regions. So since the data is replicated across regions, you can get the data in Hyderabad also. Still, your S3 data present in Mumbai, you can able to replicate the data to Hyderabad, and from their Hyderabad data, you can able to access the data from Redshift, right? Yes. So this is the way when both are present in different regions. So in this way, you can able to provide communication. Directly, you cannot provide communication between S3 to Redshift when both are present in different region. If you want to provide communication between S3 and Redshift which are present in different regions, then what do you choose? You choose S3 cross region replication. So when both are present in same region, then we can easily connect between them by using either EC2 or by using either EC2 some Linux commands, you can able to connect with them and process the data which is present in S3 or your Redshift. Now, let's say I want to process the data which is present under S3 files. Now, what do we call the data tables? Redshift tables only. Now, are those tables which are present under Redshift? No. Where they are present? They are present under S3. That is an external source. My tables are present. Can I call the tables which are present under S3 as external tables? Yes. We call those tables as external tables because they present under S3. So we call those tables as external tables. So in order to query on those external tables, do I need to configure anything on my Redshift? Yes, we need to configure external table schema. What we need to configure? We need to configure some external schema we need to configure the external tables schema under our Redshift. Same like, so what is the schema? Schema is nothing but your headings. So if you take an example of this table, the schema will be ID and name. ID type is what? Integer type. ID holds integer type values and name holds string type values. That is nothing but varchar. In this case, we call it as. So that is the schema. So in order to hold the data, first we need to define external schema and then we need to point to external table. External table. So whenever if you want to get some data or if you want to process the data which is present under S3, you need these two things. That is what? External schema and point to the external table. So by using external schema, your data is stored under that external schema tables. Where those tables are present, those tables are created under your nodes, Redshift Spectrum nodes. And which data will create these external tables under nodes? The data which is present under your S3, that is Redshift tables. So what do we call those tables as? External tables. So we need to point to those external tables and we need to create an external schema. Whenever we run, our data from external tables will load onto external schema where that external schema will present under our nodes and that will be processed and produce the results to us. Right? Yes. Let's say I want to query or process. I want to query or process the data which is present in S3 other than Redshift Spectrum. Do I have any service to query the data present inside S3? Yes. Amazon Athena. What is that service? By using which we can able to query or process our data which is present under S3? Amazon Athena. So what is this Amazon Athena, sir? So it's a query processing service where Athena allows you to query the data present in S3 by using SQL query. So what Athena provides you? Athena allows you to query the data present in S3 by using which type of queries? SQL queries. So similar to Redshift, here also we process by using SQL queries. Athena also allows us to process the data which is present in S3 by using SQL queries. Then why do I need to prefer this Redshift? I prefer Athena service, right? Why I need to prefer this Redshift Spectrum? Because if you use this Redshift Spectrum, then at a time you can able to process the data which is present in your clusters and S3. But if you use Athena, you can only process the data which is present under S3. So if you want to query data present in both S3 and Redshift, if you want to process your data which is present in both S3 and Redshift clusters, then what processing service that you use, then what feature that you use? Redshift Spectrum. That is, Redshift Spectrum can query both whatever the tables which are stored internal to your cluster and the tables which are stored external to your cluster. Right? Yes. So by using Redshift Spectrum, you can able to query both internal and external tables of your Redshift. So by using Redshift Spectrum, you can able to query the tables which are present inside internal and external tables which are present to your Redshift. So Redshift Spectrum can query both internal tables of your Redshift cluster and external tables of your Redshift cluster. So external tables means under S3, if you store tables of your Redshift, then we can say those tables as external tables. So by using Athena, you are allowed to query your data present in S3 by using which type of queries? SQL queries, right? Yes. So let's see some more detail about Athena. Okay. So Athena is a serverless interactive query service. What is it? It is a serverless, serverless interactive query service. So what does it mean, sir? It is also a query service, but it's a serverless and interactive query service, right? Yes. You can able to query your S3 data by using this Amazon Athena. Since it is a serverless and interactive query service, you can able to interact with S3 by using SQL queries, right? Yes. So what about cost, sir? What about cost in this Athena? The cost is you can pay, you can pay only for, you can pay for queries you run. So same like Lambda, here also you will be paid for only the queries. What are the queries that you run under the Amazon Athena? You only pay for that queries only. Whereas if you see about Redshift Spectrum, for what you will pay for the amount of data that you scanned on S3. So based on your need, you can prefer and choose what are the feature, query feature, that is a, if you want to choose for Redshift Spectrum or Amazon Athena, based on your need, you have to prefer among these. For querying data which is present under S3 storage. One more important note, whatever the data or files which are present under S3, those data or files which are not updated or deleted directly by using commands or queries which are sent by Redshift Spectrum or Amazon Athena. So updating or deleting for the data which is present in S3 is not possible by using either Redshift queries or Athena. So how do you update or delete the file data present in S3, sir? Simply replacing the existing file with a new file where in that file your data is updated, that is deleted or what are the existing data is updated. So that file you need to place under S3. In this way only you can able to do update or delete on file of S3. There you replace the current version of your file with new version of file so that you got your data, right? Yes. So by using commands, you cannot able to update or delete your data which is present under S3. So if you want to do, you just replace the current version of file with a new version of file where that new in that new version of file you can update or delete your data so that the data which is present under S3 new version of file will be accurate to your requirements, right? Yes. So let's see more about Spectrum supporting, Redshift Spectrum supporting data formats. What are the different file formats that this Redshift Spectrum support? You can see here, these are the different file formats that Redshift Spectrum supports. So you need to, you can store these type of data file formats under S3 so that you can able to query the data by using this Redshift Spectrum, right? Yes. So in order to perform query faster, even you can Amazon AWS will recommend you some recommendations about the data storing types in S3. If you are storing, if you are storing column type format, then it is highly recommended. So what AWS recommends you is store column format data like Apache Parquet or Apache ORC in your S3. So while storing data in S3, then while querying, query will select only the columns needed. So it avoids you unnecessary scanning of columns. So it will save you cost, right? Yes. Because of it, if we use this column format, Spectrum nodes save data same as Redshift Spectrum clusters and process the data, right? Yes. Since we are having different formats available under Redshift Spectrum supporting, depending on the format that we use, it is possible to do split reads. What type of reads? Split reads. What does it mean? Other than reading entire file in a single request, it is possible for Spectrum to split or distribute the file processing across multiple independent requests, right? If you choose this column based storage, even your data is varied by using MPP, that is massive parallel processing. So for this column type data, the data is normally processed by using massive parallel processing. So if you want to process, if you want to parallel processing of your data, which is saved in S3 for other than columnar data, then you choose, we have two ways. We have two optimal ways where we can process our data parallelly, which is stored in S3. The first way is compression. Redshift supports three types of compressions. That is gzip, bzip2, and shapi. So if you choose this compression type formats, then you also need to learn about what are the different decryption types that this Redshift can do. This Redshift can do encryption using AES 256 key management service by S3, and it also supports server side encryption by using KM. This Redshift can able to decrypt what are the files which are encrypted by using server side encryption by using AES 256, advanced encryption standard 256 managed by S3, and this Redshift can also able to decrypt whatever the files which are encrypted by using server side encryption using KMS, key management service. But this Redshift cannot able to decrypt the files which are encrypted by using S3 client side encryption, right? Yes. So only these two types of encryptions only decrypted by using S3, whereas client side encryption cannot be decrypted by using Redshift. So while using the compression, just choose these two type of encryption files. Other than those two type of encryption files, other type of encryption files, those are not decrypted. So that's why Redshift do not support other type of decryption, other type of encryption files to perform operations on that table, which is stored in S3. Now, the second type, to process parallelly, if the files are zip format and they're encrypted in these two formats, then only your data is processed parallelly by using Redshift. Or else your data is a column-based storage, then it will be automatically parallel process. Then the another way for the files which are does not comes under column-based storage or this compression, then those files, if you want to encrypt, if you want to run those files parallelly, then you need to use multiple files, that is breaking the single file into multiple small ones. AWS recommends the file size must be in between 64 KB, 64 megabytes to 1 GB, 1 gigabytes, to keep the file size consistent so that Redshift can able to process all the files parallelly with less time. At last, you have seen to process parallelly in Redshift spectrum, what are the different types of ways that you need to choose. And at last, one more interesting thing, that is, so in order to access the files which are present under S3, Redshift Spectrum requires permissions, right? Yes. So how can you able to provide that permission? By using IAM roles. By using IAM roles, you can attach that IAM role to this Redshift Spectrum so that this Redshift Spectrum will get some temporary permissions to access the resource S3 and able to access the files which are present under that S3. So one more thing you need to focus here is under S3 you are having bucket policies. In that bucket policies, if you deny this Redshift, then also you can't able to access the files that are present under S3. So you need to check the two things. First thing is you need to provide permissions by using IAM to the Redshift Spectrum by using IAM roles, and then you have not denied your Redshift to access the files which are present under your S3. By default, S3 do not deny or allow anything. So your policy will be empty by default. If due to some reasons or due to some previous configurations, it might possible that you may deny Redshift by using S3 bucket policy. So once check your bucket policy, that policy is not denied your Redshift to access what are the files which are present under your S3 bucket, so that you can able to access all the files which are present under S3 bucket by using this Redshift Spectrum. So I hope you understood this Redshift Spectrum, all the concept of this Redshift Spectrum. It's a feature in Redshift. So if you feel this, I think this video provides you some content. If you feel this video provides you some content, then please like, share, subscribe, and hit the bell icon to get the latest updates. See you back in the next video. Until then, bye bye, guys. Thanks for watching again.